Alright, in this video what we're going to look at is solving linear equations now that have two or more steps. And what we've got here is just a little key to think of, that we're going to use what we call the reverse order of operations rule to undo these complex equations. So if we have a look here at our order of operations, we've got our brackets, exponents, division or multiplication, addition and subtraction. This is generally how we apply or calculate in mathematics. What we've got here is that's the way we apply. What we're going to do, we're going to use the reverse order. So we're going to start down the bottom to actually undo. Now what I've got here is a little thing here that I've written that is about groups. And if I just bring in this little example here, some examples of groups are basically when we've got fraction form. So if we look at the example here, on the top line of that fraction, we've got x plus 4 divided by 3. Now that x plus 4 needs to be grouped together because we have to calculate all of them at the same time. So that's pretty much the same as having the x plus 4 in brackets. So that's classified the same as the brackets over here. Another example I've got here is 2x plus 3 over 2. Now what we can do is we can actually put the brackets around that, and we treat that as a bracketed expression, and we would calculate that first if we're actually working it out. But what we're doing is to undo it, to isolate the unknown. We have to undo in the reverse order, so we'll do the brackets last. Right, let's have a look at some examples of some basic questions. All right, so we've got some basic two-step equations here. All right, one thing I like to do is I like to read out the equation in simple words, and then that will let me know what the operations that I've actually applied to it. Now if I have a look at the first one here, we've got 2x minus 5 equals 7. So what are the two operations I've done to the unknown in this? Well, I've multiplied it by 2, and then I've taken 5. So if we think of the undoing operations of those, so times by 2 is divide by 2, and subtracting 5 is adding 5. What we're going to do is we're going to do them in this order. And if you have a look, it's the reverse order of operations order. So let's have a look at how that unfolds. All right, so what we've got here, we're going to write the equation, 2x minus 5. Now we're going to undo with the plus 5, so we write the plus 5 there. Remember what we do to one side, we do to the other, 7 plus 5. Now we know these 5's cancel out, and what that leaves us on the left-hand side is 2x. And that now equals 12. And when we're doing one step, this was just a single x. Now we've still got another operation where we've got 2 times x here. So what we're actually going to do is now we need to undo with the divide by 2. So our next line will be 2x divided by 2 equals 12 divided by 2. You can see there we cancel out our 2's, leaving x equals, so x will equal 12 divided by 2 equals 6. And we can put that 6 back into the equation here, where we've got 2 times 6 is 12, take 5 equals 7, 12 take 5 equals 7, that's a true statement. Right, let's look at our second example. When I read it out, we've got x divided by 4 plus 3 equals 7. So my operation that I've applied down there is I've divided by 4, and then I've added 3. So my undoing is times by 4, and subtract 3, and I'm going to work up in that order there. So let's have a look at how this looks to undo it. So the first one we need to undo with is the minus 3. So we're going to rewrite that expression, x divided by 4 plus 3 minus 3 equals 7. And now that I've minus 3 on that side, so I need to do the same to the right hand side. Those 3's cancel out, leaving x divided by 4 on the left hand side. And that equals 4. Now to undo the divide by 4, we're going to times by 4. So we've got x divided by 4 times by 4 equals 4. And because I've multiplied by 4 on the left side, I need to do the same to the right hand side. They cancel out, leaving with isolating that x by itself equals 16. So when we're solving two or more step equations, now what we're actually going to be doing is as we work down, as we undo each line, so each step, we're left with a simplified version, and then we move down and undo that next step. So what you'll find is as these get more complex, we'll just break these down further and further till we're left with x by itself. And that's what we're trying to do. All right, thanks for listening.